One of the neat tricks about Pascal's triangle is using it to find the powers of 11. So recall what Pascal's triangle is constructed just like this, where it kind of there's a trickle down effect, and the numbers on the grow and grow by units of 1. Actually, it grows by adding the two numbers together to get this bottom number, right? And it just keeps going like that. So what does this look like? Well, this, in terms of powers of 11, the first row right here, that 1 is 11 to the 0. This second row right there is literally just 11 to the first power. And what's 11 squared? 11 squared is 121, which is what we see here. And what's 11 cubed? 11 cubed is 1,331. Well, what's 11 to the fourth? 11 to the fourth is 14,641. So what would 11 to the fifth power be? Right? Well, if I use the triangle, I got 1, 5, 10, 10, 5, 1. Well, if you try to read that number, that's really weird. 1, 5, 10, I don't even know what to say. But what would happen here is this 10, just like in normal numbers, would carry over to this column, so it would be 1, 6. This 10 would carry over here, so this would be a 1. This would just be a 0, 5, 1. So it would be 161,051 would be 11 to the fifth power. Now, this is just an extension of the binomial expansion here, because in this case, 11, well, x would be, let's say, 10, and y would be 1, right? In that case, x plus y, or 10 plus 1, was equal to 11. So that works with 11, but the truth is this Pascal triangle trick works with any number. So let's try it, and let's try it with my favorite number, 13, okay? And let's say I wanted to know what 13 to the sixth power was. Well, 13 to the sixth power is this guy right here. And we're going to have to make an x and define it, and make a y and define it. So let's just choose two numbers. Let's say x is 10, and we'll call y 3. Therefore, x plus y together make 13, right? So then I'm going to use this trick right here, this row that I wrote out, which I did in another video to show that this is the same thing as Pascal's triangle. And I'm going to use that to find out what 13 to the sixth power is, okay? So if my x's are 10, I'm going to replace all my x's with 10 and replace all my y's with 3. And I'm going to keep my coefficients the same. But let's try to color code this so we don't get confused. I'm going to make this, this is my x. So 10 to the sixth, right? I got one of those. I got a 10 to the fifth here, right? I got a 10 to the fourth. And actually, it looks like it just keeps going down, doesn't it? So 10 to the third, 10 squared, 10, and then I have 10 to the 0, or just 1. I'll just leave it there. Okay, so I got that. Now, I have to put my y's in. Y's are 3. So over here I have a 3, right? Over here I have 3 squared. Over here I have 3 to the third. Over here, where I had my 10 squared, I have 3 to the fourth. And over here I have 3 to the fifth. It's not a coincidence that, and actually this should be 3 to the sixth, right? So it's not a coincidence that the 3 powers grow this way while the 10 powers grow that way. Now the last thing I'm missing are my coefficients. The coefficient of here is 1. Coefficient of here is 6. So just to not get confused, let me put some parentheses in here. Coefficient of here is 15. That is going to get confusing, but hopefully not. I'll remember. The coefficient of here was 20. The coefficient of here was 15. The coefficient of here is 6. And the last coefficient is just 1. Where am I getting this? So that's where my 6 comes from. That's where my 15. That's my 20. That's my 15. So let me write this out a little bit nicer so I don't screw it up. Okay, this is what I have written out. Now I'm going to write my tens out really quick. I have 1, 2, 3, 4, 5, 6 zeros, plus 18 with 5 zeros, plus 15 times 9, which is 135, with 4 zeros. 3 squared is 27. 20 times 27 is 540 with 3 zeros. Wow. Then 12, 15 with 2 zeros, plus 14, 5, 8, 1 0, plus 7, 29.